Test. Okay. Hello, everyone. So today I'm going to speak about self-custody. And before we start the presentation or like the masterclass, I wanted to ask like what are you currently using to self-custody your Bitcoin? So who currently doesn't have any hardware wallet or any setup, just has your Bitcoin on the exchange? Please raise your arm. Okay. Then we have a look at, so now if you already raised your arm, do not raise it. If you're now, who already has like a hot wallet where you like store your Bitcoin, your like seed phrase on your smartphone or your PC, like your private key, raise your arm as well. So now raise your arm. Okay, we have a couple of. And who already has a hardware wallet? Raise your arm. Okay. And last and not least, who has already like a passphrase or a multisig? Raise your arm. Okay. Yeah, good to know. So today I thought that most of us are going to have like a hardware wallet because a lot of don't. I'm like going a little bit now into the basics about a small introduction about what a hardware wallet does, and then we are like going a little bit deeper what really happens when you use a hardware wallet. So here I have the Bitbox app because in Germany, for example, there are a lot of people are using Bitbox. There are a lot of people using Trezor, Ledger, for example, and here we have like a small USB stick size device, and this device allows us to store the private key for our Bitcoin. I will later explain what this exactly means. I will just like get a little bit about the basics now, and we'll go in detail later on. So we have here like a device where we store our like private key on the device, and then we later on can like if we want to make a transaction, then we can probably you all like press the button here on your device, and then you can send your Bitcoin. This is probably what most of the people here did when they sent their Bitcoin with their hardware wallet, or like how you perceive a hardware wallet if you didn't use one yet. And most of you probably where I have it. Are having like a piece of paper or something where they wrote down a backup. So like 12 or 24 words that like represent the private key and that you can use to restore your Bitcoin if you lost your hardware wallet. So this is probably like the situation most of hardware wallet users here are currently in, and probably the situation most people here without their hardware wallets are going to get into next, because I think if you currently don't have a hardware wallet and you are having Bitcoin, then like you don't have to think about a passphrase or something. The most important step is like to get your Bitcoin off the exchange and maybe like buy a hardware wallet and store your Bitcoin on there and do like this little setup which I like spoke here. And now we can go a little bit into detail and find out what is really happening inside our hardware wallet and inside what happens here. So what I wanted to add here now is here I have the Bitbox app and I have a device. So we always need two sides, like on the one hand an app on the PC or on a smartphone, and an extra device, the hardware wallet. Okay, so what we are going to do now is create like a complete new setup, like a new wallet and everything, and I will explain in the process what we are doing. So for this reason, I've brought another hardware wallet. This is a Spectre DIY, or in this case, Spectre Shield Metal. And here, I think the process is a little bit more transparent as at the Bitbox, for example, or at other hardware wallets that has a smaller touch display and are connected to your PC directly. And I'm going to show it here because it's a little bit more transparent what's happening exactly. And because the hardware wallet is a little bit small here, and most of here wouldn't see really what's happening when I use the hardware wallet, I also have here a simulator of the hardware wallet. So I can show you what I'm doing here at the hardware wallet. Okay. So what you first, of course, if you have like set up your hardware wallet, so this goes with every hardware wallet, just to let you know. At first, this what I'm showing here goes for like 99% of all good hardware wallets. Of course, there are like hardware wallets that pretend to be a hardware wallet, like if you have only a card and nothing else, and I wouldn't even think this is a hardware wallet. But anyways, let's have a look how this works. So here, the one thing about Spectre is you can like navigate inside the hardware wallet, and this allows us to like make everything a little bit more transparent. Okay, so now we set it up and we can enter our pin code. So in this case, so normally you would like set our first pin code. I just like press here next because I already set it one, but if you would like get a new hardware wallet, then you of course would set one. And now what we are doing is creating our Bitcoin seed phrase. So these are like the 12 words or the 24 words I showed you at first, which are necessary to restore your Bitcoin if you lose them. And these are very important, and nobody should see them if you like generate them. And like because if someone sees the seed phrase, then they can steal your money on all the Bitcoin on the wallet. So this is like very sensitive data, and normally you wouldn't do this in a crowd of this here. But I'm going now to generate a new seed phrase here. Now I have one. So there is in the hardware wallet, so every hardware wallet does this, there's like every good hardware wallet has multiple levels of entropy for generating the seed phrase. So different like randomness generators inside of the hardware wallet that these words are as random as possible, because these are not like really normal words you would pick from a dictionary. They are, but there are like only 2048 different words you can choose your words out of. And the hardware wallet does this for us, because if we would choose the words ourselves, then there is the problem that you maybe like get words that are other people also thinking, because our brain is not perfectly random, of course. And if we choose them from the list, I also have the list here. Where is it? Here. This is the list of all the different 2048 words. So there's like they are numbered. Here is the number of the word. Here's the word, and this is like the binary representation of the word. I come to it later. And so I wouldn't recommend. I would completely not recommend to like choose a couple of words here, because maybe someone would like choose the same ones, or like an AI gets trained on and tries like 100 million per second, and then gets like the same you would choose. So you would need as much entropy, as much randomness as possible in this generation. And the hardware wallet, like I said, does this for us. But now, as I want to make this process as transparent as possible, we are going to add transparent real-life entropy into this generation. Let's go back to our, where is it? Our hardware wallet. Here's our hardware wallet. And on the one hand, we can choose if we want to use 24 words or 12 words. In my opinion, I think 12 words are completely enough, and there is no security benefit to use 24 words. Maybe if you have questions about that, we can go to it afterwards if we have time. But so I'm going to start with 12 words here, because it's also easier to handle. Okay, so this is not possible with every hardware wallet. This is just with the Spectre possible, but this makes like the generation of the seed phrase a lot more transparent, and this is what we're wanting to look at today. So I click here on the first word, and we can see here the binary representation of this word. What does this mean? Let's have a look here at the list. Oops. So we can have here in our hardware wallet see the number of the word list. So if we scroll here, it starts with 0 here in this list. With Spectre, it starts with 1. So just that you are not confused. If we swap here all our bits, then this is like here. Here it says 1. In our presentation, it says 0. So we must think a little bit, but I think you get it. And now we have only zeros here. So if we don't mark the bit, this is all a bit. So this is these are the bits, because every word, like you see here in this list, is a digit, a number, and you can see this number also as zeros and ones. That's what computers are using. And so this here are only only zeros, so we get the abundant word, which is here. And now we could like click the one here, or wait. We can click the one here, so we have like activated this bit, and now we see ability. So this is like it's working, and what we can do with this knowledge, when we know, okay, every word is like a number of this 2048 words, and every number can be represented in like zeros and ones. Then we can also add real-life entropy in our seed phrase generation. So we can, for example, use coins. So I have prepared here 11 coins, and we can use them to generate real-life randomness for our generation of the seed phrase. So this is just for like very paranoid people. Normally you don't have to do this. This is just for understanding what's happening inside of the hardware wallet. So if you're really paranoid, okay, you can like add with coins or with dices entropy into the generation. But I think for most people it's not necessary here, just to mention this. Okay, you can't see this here, but I just like thrown a couple of dices, a couple of coins, and now we could like say, okay, we have here we have head, so we like activate if we want to, if we look from this side, if we activate the first bit, and then we go to the next. Don't activate it as is a tail. Activate it as is a head. Tail, we don't activate it. Tail, don't activate it. Tail, don't activate it. Tail, don't activate it. Head, activated. Head, activated, and tail, don't activate it. So this would be like a random generation of the word, and then we would get here J's, and now we could look at this list if this is like exactly the word it should be. So let's try this with one word. So it should start with a 0. Then there should be 2 1s, or we can even have a look at this number here, 774. Where do we have it? Where? 774. Ah, here. General. It's gaze. Yeah, it's like I said in the beginning, it is like one above, because this list starting with 0 and Spectre is starting with 1. Okay, and now we can have a look if the words match. So here's a 0. This is this 0 here. Here's a 1. This is a 1 and a 1. 0 0 0 0 0 0 0 0 0 0. Wait, I'm confused here. So wait. Wait, now I lost the point. Ah, yeah, okay. Here is 1 0 1 exactly. Okay, so now we know like how the computer or hardware wallet like uses the seed phrase. Like the computer it uses just these numbers, and we would be even able with some hardware wallets to like have a look at the exact bits what the hardware wallet is doing. And if we are very paranoid, we can like do this generation with coins with every single word. But like I said, most hardware wallets have like very much entropy into the generation, and you like normally you don't need to do this. But if you have like very big amounts, then you think, okay, maybe like the entropy could be not perfect, and then you could do something with coins or something with dice or something. Yeah, okay. Now what we need to do if we have a hardware wallet, of course, we need to write down this Bitcoin seed phrase. So I'm too lazy to do this right now, so I'm just going to make a photo. But this is something you never should do in a real scenario, because your photo maybe it's synchronized with your cloud, then it's already in your cloud. Your Bitcoin are like gone. Yeah, exactly. So you should never do this. I could write them down as well, but okay, we do a screenshot here. But like I said, this is like very okay. Yeah, she. It's very kind. Okay, let's go. Yes. I know. I just screen. She writes them down. So you can already write them down. As I'm wait, where do I have it? I'm not sure where the screenshot is. Yeah, that's. Yeah, just write them down. Shall we? Yeah. Shall we write them down? Yeah. So maybe like I even have paper here. Maybe give it 2 copies. Okay, now we are making our analog copy of the seed phrase, which is very important, because I can explain right now why we should. do this if so this is like right now happening on our hardware wallet. We have like the seed phrase right now on our hardware wallet. And the thing is, if we later on lose our hardware wallet, then all our Bitcoin would be gone if we don't have a backup. So a backup is very, very important. You should always have one, or even multiple. So because if you lose your hardware wallet and the backup, then your Bitcoin are gone as well. So you'd consider like having like maybe another backup. And I'm going to explain later on how we should like secure this backup. At first, yeah, we now have. Can you hold it up? Okay, so we have a backup right now, and you can like write from her, and we click next, and now we like have created our backup. So this, like I said, we can do with every hardware wallet. And what we want to do now is we want to connect our hardware wallet with our PC. If we use, for example, a Bitbox here or like another hardware wallet, then we would plug the hardware wallet into our PC, and then the PC would like see, okay, there's a hardware wallet connected to our PC, and then, or like we need some software for it, like software wallet, for example here the Bitbox app, or Sparrow wallet is an application like a software wallet or companion app we can use with every different hardware wallet. And this would recognize that we have a hardware wallet, and then we can like connect it and see all the wallet information in our wallet. So if I would do this with Bitbox, then we would be here logged into our wallet, and currently there's nothing in. Now we want to have like a transparent way to see what we are doing, and this are we going to do with our Spectre hardware wallet. We do this together with Sparrow wallet, and now we like generate a new wallet and connect it with our hardware wallet. So we press go here. You don't have to like really go into details. You don't make notes or something. Just wanted to show you what how it would work. So we would like enter a name for our wallet. In this time we say Lugano test wallet, create wallet. Now it says here something because it recognizes the Bitbox. In this time we don't want to use it with Bitbox, we want to use it with the Spectre simulator here I showed here. So can I... So now we see both. Here we have a couple of different settings. On the one hand, we can choose if we want to have a multi-sig or a single signature wallet. Most of you probably a single signature wallet would make the most sense. So we are going for this one. And then script type. What does that mean? So there, in Bitcoin, we have different address formats, and we can use like different types of addresses to store our Bitcoin on it. And normally we would do here native SegWit, because this is like the most common address format we are using. So most hardware wallets support different address formats, but like native SegWit is currently like the one most of you should use, because the fees are like the like smallest, and there's also like Taproot, but I think this is too new, so I would go for native SegWit if you would have the choice. Most hardware wallets automatically choose native SegWit. So what do I mean with address format? I will come to this in a couple of seconds. At first, we are going to connect the hardware wallet to our PC. In this time, we press here air-gapped hardware wallet. Scroll down to the Spectre, and normally we could now. I'm going to. I can't do this. So normally with Spectre you would see a QR code on your hardware wallet, which you could scan. So this is like, there are different communications between the hardware wallet and the PC. So like I shared in the beginning, Bitbox or most hardware wallets do this with cable, or some with Bluetooth. Some are like more like called air-gapped hardware wallets, are working with SD card or with QR codes. This is like called air-gapped because there's no physical connection to the PC, and this is considered more transparent because there's like a short period of time where some communication is happening. Like I said, we could like scan it here, but I'm going to do this with SD card. So I click here, import file. All right, I need to like store the file on my SD card. So we have a virtual SD card here in our simulator, a virtual SD card slot. So we got here a master public key because and single key. So what does master public key mean? This is the XPub of our wallet. So from the seed phrase we wrote down, we can derive different private keys for our wallet, and also like public keys. And this is the master public key. So not this one here, and we can derive it. So it just goes in one direction. We can every time we can get from this Bitcoin, this seed words, we can get to the master public key right there. So like do you see my mouse here? This text here. You can basically see this in every hardware wallet. So every hardware wallet has a different communication style. Where are this text here is like connected to the PC, and now we do it manually, save to SD card. Now it's saved, and I need to go to the SD card here. The second one. I need to like open it. Import file. Where do I have to? Or can I? Nee, I can not drag and drop it. So this is like the simulator, so it gets a little bit complicated. Normally you would like plug it into your PC and you would instantly see where do I have it? It was the second one, right? Oh, so what is important if we are like manually can edit our hardware wallet, then we can be in the testnet or in the mainnet. So there are like two different networks so like there's one Bitcoin network, of course, but for like developers or people who want to make like small transactions or like demo transactions, there's like a copy of the Bitcoin web network where the coins are worthless, and I'm showing it right now with this test coins. And what I need in order to do this is I change the hardware wallet in this testnet. So I already did this with Sparrow wallet. Now I save it again in the at SD card. Oh shit! Now it should be this here. Okay, now we imported it, and now we can like load it into our PC. Here, Sparrow Wallet gives us the option to set a password. Why do we could have a password at our PC? This is not related to our hardware wallet. We can't get on any like sensitive, so any data that about our private key or something with this password. This is just to make sure that someone accesses our PC, that you don't want to see how much Bitcoin is on our wallet. It's not about like stealing the Bitcoin. For like demo yeah, okay. Now we just take no password here, so you could consider this on your own. What makes sense for you to use?
Without a password, if someone finds the device, they have access, correct?
No. This is not the password for our hardware wallet. The hardware wallet is here. So the hardware wallet is here, and we can like enter a password for our hardware wallet always on the device. We can't do if we have a password on the PC. That's like a complete different type of thing, because we can only like encrypt or our like personal data about the data, how much Bitcoin we have and everything, and not the private data on our hardware wallet. Okay. So now we can see everything in our wallet. On the one hand here, our transaction where we don't have any. And we could here send our Bitcoin and receive. This is the address I mentioned. And now this is the SegWit address format. Like normally, I can show this in the bitbox. And we would have like here BC1Q addresses. This is the normal address format, like this native SegWit address format I spoke earlier. Here in Sparrow Wallet, I said it's testnet, so the coins are worthless, and it's not actually Bitcoin, so the address format is slightly different. And now what we can do is like receive our first Bitcoin. So what we would do to do this is we would copy this address here into so for all of you who has the exchange would probably give you the option to insert the address where we can send our Bitcoin to. And this is the address we would give the exchange. And yeah, this would we copy this, enter it on our PC, and then we could send out the transaction. In this time, we copy it, and I have another wallet here. It's a hot wallet, so we can make this transaction. We don't need a exchange for this, but it's basically the same process. So I press send here, enter the Bitcoin address. In this time, so this is like a hot wallet. So I already spoke about hot wallets in the beginning, so that the private key, which we wrote down here, that this key is not stored on the hardware wallet, but on the PC. I'm going to write a label because Sparrow Wallet wants to do this. This is just for internal, that you have a name for this. And oh shit, I'm not. Oh shit. So I'm currently not connected to the blockchain. Shit. So normally, you would be connected to the blockchain. I have internet. Okay. Okay, now we are connected. Sorry for the delay. And yeah, I sent a transaction just. I don't know, 100,000 satoshis. Send it out. Broadcast it. I will go to this process in a second. Just wanted to like send the Bitcoin out, and now we can like do the transaction the other way around with our test wallet we have here, so with our hardware wallet. So what we're doing here is we search our address we want to send the Bitcoin to. So at first we like received it from our exchange. If we want to send it back, we could do this now. So we could do, for example, a penny test. That's called if you make a small transaction in the beginning after you created a wallet, just to make sure that your wallet is working properly. So we can do this right now, like send the wallet just back where we received it. I go here and like this is the hot wallet here, just not to get confused. I copy the address here and send the Bitcoin back now. So we go to send and send the Bitcoin. I paste it here. Then it asks us to enter a label. And this is, like I said in the beginning, it's just information about where we want to send the Bitcoin to, or like some information about the Bitcoin or the coin later, just for ourselves, that if we have like sent the Bitcoin around, then we know, okay, this was this Bitcoin, and maybe for privacy reasons this could be beneficial, that we don't want to like share specific Bitcoin with mix specific Bitcoin with other Bitcoin. For example, Bitcoin we bought from peer-to-peer, so from other people, or like from exchanges where they have our data. So we shouldn't like mix them. And this is like one option to have like a label here that we say, okay, this is KYC. I don't know, what do we have here in Switzerland? I think Pocket Bitcoin. And this is what could be a label. We could label it, and then we know, okay, we received this from Pocket Bitcoin. Then we can do a amount. So I said it was a penny test. 100,000 sets would maybe a little bit much for a penny test, but yeah, we can set here the maximum amount back. It already like set it here a fee, so the amount we need to pay to the Bitcoin miners in order to make this transaction. So here we see the transaction in Sparrow Wallet. So we see this is the so who knows what UTXOs are? Please raise your arm. Okay, a few, so I will explain this. So on every address, and every address are like a Bitcoin, so or like a small amount of Bitcoin. We have this here. So so this here are all the addresses of our Bitcoin, or I just like forgot some important thing on this in this part. Before we receive Bitcoin, we always need to check the address of our what we see in our companion apps like Sparrow Wallet, or like on our other hardware wallet. We need to check if the software wallet and the hardware wallet have the same address, because if your software wallet got compromised and it shows you like here, this are like all the addresses we have from our wallet, and if it shows us the wrong addresses, then we should like check this with our hardware wallet. And I can do this here at the hardware wallet we have in the simulator. So I can go here on wallets, and this is like the normal wallet we chose. And now we can check here if this is like the same address. And here we can see this is like exactly the same address, the first one. And now we can like easily receive the Bitcoin too, which we already did. And if we like do the process backwards, we should also check the address here we receive Bitcoin to when we send the Bitcoin. So I'm going to do this now. I'm going to send a Bitcoin transaction. We can close this one here. I'm going to send, we already wrote down here everything. Now, what I wanted to say is the UTXOs, right? So, like, we have all these different addresses, and on every address we have a specific amount of Bitcoin. And you can think about it like some money. So we have like here 50 euros on our address, and then we have like another address which we also control, and we have another 50 euro or even another amount of money on our address. And then we have like, for example, here 3 addresses with different amounts on it. So this is all here like different addresses, and these are all like UTXOs. And now if we want to make a transaction, then we use a couple of these UTXOs. So this is just imaginary to send our Bitcoin. So here in this case we only have one because we just inserted one UTXOs, but here could be also like different of these inputs of this transaction, so different UTXOs we sent the Bitcoin from. In this case it's just one, and in the output here these are new UTXOs that are created. So we have like, we would import here one UTXO, on the other hand we have another one, and in this case it would the UTXO we sent we like get out would be a little bit smaller than the one here, because we have a small fee we pay to the miners, the Bitcoin miners who mine Bitcoin. This is like why the amount here at this area is a little bit smaller than the one we put it in. Okay, now we create our Bitcoin transaction, and now we send our Bitcoin transaction. So finalize transaction for signing. And what's now important, that like if you have like connected, if you use like a USB stick hardware wallet, then you would now see, okay, if you would like some send transaction or something, then you would see the transaction on the hardware wallet, and you would see especially the receiving address here, this one. This is very important, and you should confirm this receiving address on the device, so that you can be sure that the address that is shown here in the software wallet is the right one. Because, like I said, if the PC is compromised, it could show like the right address, but in the background it tries to sign an address to which goes to the hacker. And in order to prevent this, we can like have a look at the hardware wallet. And in this case, we do it here with our simulator hardware wallet. So this like, and we do this also with the SD card in this scenario. So we save the transaction on the SD card. This was the SD card here. So we save it. And now we can go here in our hardware wallet and open the SD card. So now we are back in our hardware wallet, put the SD card in our hardware wallet, and now we can see, okay, here's our Bitcoin transaction. So I have a couple of them here, they're not important, but this one is the one recreated now. And now we can like import this transaction into our, like load this transaction. And now we should see exactly the same transaction here in Sparrow wallet as we see in our hardware wallet. On most USB stick hardware wallets, we would now see like I said, the address here, then the fee. Here in Inspector, we can see like a lot of more details. We can see exactly this input, this here, the output to this Bitcoin address here, at the fee we pay. This is like a contract we like imported in our hardware wallet, and we need to sign now. So I'm checking if this is like exactly the right address. So you can do this also if you have like good eyes, and see if this is the exact same address as this one.
There is no automated way of doing it.
What you said?
There is no automated way to check the addresses.
There's no automated way, yes. So you need, this is a thumb thing you need to do manually. You need to check. So there are some people who say, okay, I just check a couple of the first 5 or something. That's not enough, and because there's like automated ways that you for example that you attacker knows, okay, this is like the right address. And yeah, then they compromise it and they try to like have a similar address, but it's one from an attacker, and then it like looks very similar, the address, but it's a different one. So they can't completely do this with the whole address, because it would there are like a lot of different versions, but they can try like to get like maybe 4 different ones. I'm not sure how many computer power you need, but it is possible. And some of these viruses are doing this. We saw this at the NPM attacks. They tried this. And so it would be best if we like check every single number of this transaction here. So of the address. So yeah, I did this now. And now we can confirm this transaction on our hardware wallet. And process request is saved. So yeah, we could like show this as QR code here, or send it here on like store it on our SD card. Here it's in a QR code form. So normally you would just scan it with QR code like this. Show scan QR code. Oops. So here would like be a camera, and then we could just scan it with our like device. Here in this case we are doing this not. We are doing this with the SD card version. Load transaction. Here we have like the unsigned transaction, and now we have also in our SD card the signed transaction. This one here. We can open this now, and now we see, okay, the transaction is signed, and now we could send out our Bitcoin transaction. Great. And now we did like a test. Okay, our wallet is safe, and now we could send bigger amounts of money on this wallet. What we need to do, no, we don't need, not yet. So what we also would need to check is that we like remove the power of the, so like forgot the everything of the device. So you with USB stick so there are some hardware wallets do like a test where you need to input some of the words we wrote down. Some hardware wallet does not, so you need to like delete everything. Just like testing the scenario if you would lose something and if check if your backup would work. So I can do this here.
When using the test, do you have to still wait 10 minutes for?
Yes, we need to. So sounds yeah. In this time I'm like rebooting the device so that it's delete everything, and so this is like starting the simulator. And now we would like enter our pin code and enter our like seed phrase again. And then we should like check if we would get like the exact same addresses as we get in the initial one, and then we could like also do like, maybe it would be best like to do the penny test after you like typed in your seed words again into your hardware wallet. As we have not enough time, I'm not like typing it in here, but this would be something you could do. I'm like wanting to like add some other important stuff on what we should do with the backup, because this is very important and you want to make sure that no one gets this, because your hardware wallet is protected. So if you like store it on the hardware wallet, then we have a secure chip inside. Here with Spectre, we have the possibility to like remove it and see the secure chip. This is like a smart card, like most banking cards have a secure chip as well. So this is something we where we store the Bitcoin on most hardware wallets. And yeah, so in this time we like insert the chip into our hardware wallet and then store it. So I can there's no smart card inside. Wait a second. So we store it onto the smart card. We would do this manually with Spectre. Most hardware wallets do this automatically. Then we encrypt it with the smart card. And now if we would like enter 10 times in a row the wrong pin code, then we would like the hardware wallet would, so the secure chip would be broke or would be reset, and we won't be able to access the seed phrase. So the thing we wrote down, we wouldn't be able to access this from our seed phrase, from our hardware wallet. Sorry. Yeah, this is something important to know, that if you like choose a pin code now, so I'm running a little bit of time, so I'm like going a little bit faster now. If we chose a pin code now and someone would steal the hardware wallet, then this person wouldn't be able to access your Bitcoin or the seed phrase, and because it's like encrypted with this pin code, and yeah, it wouldn't be able to, because if you would like wrote it down 10 times in a row or 10 times in general wrong, then you would delete everything, and we need to rely on our backup. Okay, now quick, what do we do with this backup? I would recommend to not just store this as a plain backup in our somewhere. I would like maybe put this in a Trezor and in a safe. And what I think is very important is that we use these tamper evident bags. So you can buy them from different companies. I think it's very important to have like this backup in like some kind of way that you can't see through, and then to put this backup into this tamper evident bag. And then we like close this tamper evident bag, and the important part is here that this has a unique number. So we, of course, we would like put it here in, close it completely, and then we can like tear off this number, and we can like put this in our safe. And like in 2 months or like 2 years, we can go to our safe and check with this number we have if this like exactly the same number, because no one, if you would recognize if someone would open the tamper evident bag, and you would recognize with this number that no one like changed the bag. This is like very important in my opinion, to have like every backup inside of this tamper evident bag. Yeah, and then of course, if you want to like have an even more secure way, because you think, okay, maybe there's something with the safe, you could like do another backup at another safe if you have like enough secure places. But of course, this also has the risk that if someone finds this backup, then he gets like access to your Bitcoin. And if you want to like make sure that if someone like finds your Bitcoin, doesn't get access to your seed phrase, I would recommend, so this is like the next step if you want to have an even higher security level, to set a passphrase. This is just really quick, like an extra word you put to the seed phrase, and you would need to enter in your hardware wallet, and with an extra word you would get another set of addresses, another XPub. You would connect this to your PC as well, and then it's if someone finds your seed phrase, you wouldn't directly get access to your Bitcoin, and you would be able to see that and make another seed phrase, send the Bitcoin with your other backup you have, or with your hardware wallet where you start the seed phrase on, to another wallet with the passphrase, and then you would be safe. And this would be like the option you could do with passphrase. But at first I would think it makes sense to start with a normal wallet, and then if you want to have more security, then you can add like this passphrase layer I speak about. But I think how much time I have is it? It's okay. So yeah, this was my masterclass about self-custody and how to do it and what happens there. Hope you enjoyed, and now we have another speaker.